in the area, they ask us to identify a couple different pieces within each shape. So let's see. Let's start with area of a triangle. We'll start with this example right here. So this will be like our number 1. All right. So first they ask for F. F stands for the formula. So what is our formula for area of a triangle? Good. All right. What is the base of this triangle? 12, and the height, 8. So if I was to plug that into the formula, which is what they want me doing on the first line, 1/2 base, which we said was 12, times height, which we said was 8. And then in the last line, we're going to put our actual simplified answer. So I've got 1/2 times 12, which is 6, and 6 times 8 is 48. All right. And we do need to make sure to include the units, so this would be 48 inches squared, since our area is in units squared. Okay, second one right here. We're looking at this problem here. Again, it's a triangle, so same area formula, right? What's the length of the base here? 9. Okay, are we given the height? No. What can we do to find the height? Pythagorean theorem. So what's it going to be? 4, right. It's a 3, 4, 5, right? All right, so then I just plug that information in. Okay, so I've got 1/2 times 9 times 4, which is going to give us 18. So with our units, that would be 18 feet squared. All right, and then here's our third triangle example. Again, since it's a triangle, still the same formula. So we got 1/2 base times height. What is the length of the base? Do we know? We can find it, though, because this is what kind of a triangle? A 30, 60, 90. All right, what do we label the side across from the 90, the one that was given to us? 2x. Okay, so 12 equals 2x. All right, across from the 60, what do we label the side across from 60? X what? Square root of 3. And what do we label the side across from 30? X. All right, so if 12 equals 2x, what is the length of my base? 6 square root of 3. So this side would be 6 square root of 3. All right, and then what would be the length of my height? 6. All right, so we've got 1/2 6 square root of 3 times 6. All right, we don't want to put that in our calculator because it's going to give us an irrational decimal, right? A decimal that keeps going because there is no square root. So remember, we treat a radical like a variable. So you pretend it's an x. You can multiply the things in front of it, but you don't actually multiply the radical itself. So I would do 1/2 times 6, which is, and 3 times 6, which is, so the area is 18 square root of 3. And they didn't give us a unit here, so we're just going to put units squared. All right, so just a reminder that even if they don't give you the base or they don't give you the height, you can probably solve for it using one of the rules you previously learned. Okay, now we're going to look at an example of a parallelogram, square, and rectangle. All right, so let's start with the parallelogram. They remind us that the formula for area of a parallelogram is what? Base times height. Okay, so do we know what the length of the base here is? Yes, what is it? 12. Do we know what the height is? No. The height would be this line right here. Okay, they did, though, tell us that this is 30, so this angle up here must be what? 60. Okay. So, again, what do we label the side across from 30? x, which is the piece that we're looking for, right? And which piece did they give us? 2x. So what is x? 4. Okay, so just a reminder that for your 30, 60, 90, if you don't have it memorized, which you should by this point, there's your chart. All right, so now I just plug that information into the formula. So base times height, which is going to give us what? Good. So we'll have an area of 48 meters squared. All right, that second figure, they say it is a square because they mark all the sides to be congruent and it has right angles. So we know our formula is also base times height, or can also be referred to as side squared, since all of our sides are congruent. Did they give us the length of any of the sides? No. But what do we know we have two triangles of? 45, 45, 90s. Okay, and in the 45, 45, 90, what do we label the sides across from the 45s? X and X, and across from the 90? Good. All right, so we know that x square root of 2 is equal to what? Good. So now we just need to solve for x. So what am I going to do to get x by itself? Divide by the square root of 2. Right? And we do typically want to get the radical out of the bottom, but remind yourself, I'm going to end up squaring whatever I get, right? So it's going to get rid of itself on its own. You don't have to rationalize the denominator. But if you get to the final answer and you still have a radical in the bottom, then you would need to fix it, okay? So one of our sides has a length of 24 over square root of 2. So area can be found by squaring 24 over square root of 2. Remember, squaring something literally means multiplying it times itself. So I would multiply the 24s in the numerator and the square root of 2's in the denominator. What is square root of 2 times square root of 2? 2. So whatever I get when I multiply the top, I'm just going to end up dividing by 2. Okay? So what are we going to get there? Right. 576 over 2, which is going to give us 288 inches squared. All right, last one here on the front, we've got a rectangle. So we know our formula, base times height. Do I know the length of the base? So what am I going to have to use? 30, 60, 90. All right, so which piece did they give us? 2x. Okay, so we know 2x equals 15. Okay, the base. Would my base be labeled x or x square root of 3? Right, this part would be across from the 60-degree angle. So if 2x equals 15, what is x? 7.5. So what's my base? Good. All right, and what's my height? Good. So to find the area, all we're doing is multiplying those two terms together. Remember, we multiply the numbers in front, but not the radical. So what is 7.5 times 7.5? Good. So our area is 56.25 square root of 3 inches squared. All right, flip it over onto the back. We got an example of a rhombus. Okay. So for our area of a rhombus, it says we should use the formula 1/2 diagonal 1 times diagonal 2. Okay, what is the length of diagonal 1? What is the length of, okay, you said, not 20, 40, or 30, like Lance said. They didn't specify which one's diagonal 1 and diagonal 2. They said this part is 20. That's not a diagonal. It's the whole line, right? So 40 for diagonal 1. What's diagonal 2? 30. So it would be 1/2 40 times 30. Well, what's 1/2 times 40? 20. And what's 20 times 30? Good. So 600 yards squared is our area there. Remember, guys, that a diagonal goes from vertex to vertex. And because it's a rhombus, we know that the diagonals are bisected, so we know they're equal in size. All right, then we've got our kite. Also has an area formula of 1/2 diagonal 1 times diagonal 2. All right, so I know a piece of one of my diagonals, right? I know that this piece of the diagonal is 12. But I don't know the top half, and it's not equal, right? It's not something I can double. And I don't know any of the values on this portion here, right? But because this is a kite, if this piece is 15, then what's this piece? 15, good. All right, so then what could we do to find this piece here? Pythagorean theorem, right? It's also one of our triples sorry, the other way around. So right here, we end up with what? 9, right, for one of our triples. And if that piece is 9, then I would also know that piece is 9, right? Because that one diagonal is bisected or cut in half at that point. All right, so what would be the length of that diagonal? 18. All right, but we still have to find this piece to complete diagonal 2. Okay, so what could I do to find that piece? Pythagorean theorem as well. This one's not one of our triples, so we are going to have to work it out. So x squared plus 9 squared equals 13 squared. All right, so 13 squared is
169.
All right, and I would subtract 9 squared from that. 9 squared is
81.
All right, so what's 169 minus 81? 88. Good. So I have x squared equals 88, right? And then I have to take the square root of both sides. There is no perfect square root of 88, but we do need to simplify it as much as we can. So what's a number that will multiply to give us 88 and has a square root? 4 and 22, right? And the square root of 4 we know is, so this could be rewritten as 2 square root of 22. All right, so this part right here is 2 square root of 22. So the entire diagonal here would be what?
14 square root of.
So just to remember, we treat this like it's a variable, right? So this is like 12 plus 2x. Can I add the 12 and the 2x? No. So I would have to literally write this diagonal as 12 plus 2 square root of 22. So whenever we go into solve this one, because you are going to have to keep your diagonal 2 as 2 separate pieces, whenever you multiply, you'll have 1/2 times your diagonal 1, which was 18, times your diagonal 2, 12 plus 2 square root of 22. So we've got 1/2 times 18, which is 9, and then I'm going to have to multiply the 9 times both of these pieces, right? So it's kind of like distributing a 9 into this parenthesis. So you first have 9 times 12, which is 108, plus 9 times 2, which is 18. So this will become 18 square root of 22. And they didn't give us units here, so just units squared. Okay. You also, because you had to leave this one as separate ones, this is one where sometimes they will just ask for the decimal answer. So if you were to give me the decimal answer here, I would say just round maybe 1 or 2 places. Don't go too far with it. Okay. All right, so let's look at our last section for trapezoids. Okay, so our formula for area of a trapezoid. Remember that is 1/2 base 1 plus base 2 times the height. All right, so do we currently know what the height of this trapezoid is? No. Because remember, the bases of your trapezoid have to run parallel to one another. So these are the bases. And your height has to be perpendicular to the base, meaning your height is this line right here. So I'm looking for that piece. What could we do to find it? Pythagorean theorem. It's one of our triples. So what's it going to be? 4. All right, so this piece here was 4. All right. And then base 1, what's the length of base 1? 6. What about base 2? 9. Good. Because if this side is 6, so is this, right? And you just attach that 3 to the end of it. Okay, good. So now we plug it into our formula. We're going to have 1/2. And then our base 1, we said, was 6. Base 2, 9 times the height, which is 4. So parentheses first, right? So we get 15 in there. 15 times 4 times 1/2. What's that going to give us? 30. Good. So 30 feet squared. All right, last one. Okay, what's our formula here? Same thing, right? Okay, but it looks a little bit different. Okay, so for this one, again, do I know the height? No. So the height has to be perpendicular to the bases, which are the 2 parallel sides. Okay, so what kind of a triangle do we have? 30, 60, 90. Okay, and the height, is it going to be the x squared root of 3, or the 2x? X, right. And which piece did they give us? 2x. All right, so if 2x is 8, what is x? So we know that our height is 4. All right, and what was base 1? Good. And base 2? 8.2. All right, so now I just need to substitute that information in. So I've got 1/2 times base 1 plus base 2 times the height of 4. All right, so we add our 6.4 and 8.2. We multiply by 4, we multiply by 1/2. What are we going to get there? Good. 29.2. This one is meters, right? So meters squared. All right. Yeah. Well, if this is 6.4, this would be 6.4. So 8.2 is the whole thing. Oh, I see what you're saying. I see what you're saying. Like, oh, because this one's a little bit longer on this end. Yeah, they didn't specify, did they? We'll do it both ways. We'll consider that it could be either or. Okay, so let's consider that it isn't. I'll make sure on the assignment that it's more clear. Okay, so that would make this portion here 4 square root of 3, right? So then we could say, or this base could have been 8.2 plus 4 square root of 3. So then in this spot right here, this is what we would have plugged in, and we would have solved similarly to above. I'm pretty sure they did just mean that the whole bottom was 8.2 because they didn't say, you know, like normally they would bracket if it was just this part and put the number underneath. But yes, if they don't, then you're right. You could also assume that you're supposed to do this right here, plug it in. And then it would be kind of like the one we did up above, so make sure you distribute to both pieces, all right? Thank you for pointing that out. Very good.